Hi everyone, and welcome to the third video for simultaneous equations. In this video we'll be looking at how we solve the simultaneous equations by the second algebraic method, and that is the elimination method. So, to solve by elimination, as I've said, it's another algebraic method of solving the equations. What we need to do here is to actually add or subtract the two equations. What this does is it eliminates one of our variables x or y, or t or c, or n, or whatever the variables are called. In general, we need to follow this rule. If your equations have the same signs in the middle, so if they're both adds or both subtracts, that means that you need to subtract one of your equations from the other. If they have different signs, if one of them is a plus and one of them is a negative, you need to add your equations together. This is so that one of your variables is cancelled out. Again, before we can do this though, we need to make sure that this variable we're trying to eliminate has the same value. And to do this, we need to multiply one or both of the equations. Okay, so we pick a constant, a number, to multiply the equation by to make it the same as the other one. This is what allows us to actually eliminate one of the variables. Take some time just now to write this into your notes jotter, please. Okay, here's example number 1 for you. So we want to solve the system of equations 2c minus 3t equals 3 and 5c minus 3t equals 12. As we did with the substitution method, we're going to start off by labelling these 1 and 2 so that we can refer to them throughout. Now, by looking at these two equations, you'll see that they have the same signs. They're both takeaways. Same signs tells us that we need to subtract one of the equations from the other. We're looking to eliminate one of the variables, so we'll want one of these to have the same number before it. We can clearly see that the c terms, one is a 2 and one is a 5, so they're different. But if we look at the t terms, they're both 3, so we have the same value already. So if we have separate signs, the same signs, we want to subtract them. Now we're looking to subtract c terms, t terms, and constants. I ideally want to be left with a positive answer at the end. So I don't want to do 2c take away 5c, it's better to do it the other way about. So we're going to take equation 2 and we'll take away equation 1 from that. So if we look at the c terms, 5c take away 2c, that leaves us with 3c. Then we have negative 3t take away negative 3t. And remember, when you take away a negative, you're actually adding, so it's negative 3t plus 3t. That gives us 0t. That's what we want to happen here, because that is eliminating that variable for us. We then have the equals, and we have 12 take away 3, which leaves us with 9. Now we're left with a nice straightforward equation. We've got 3 lots of c equals to 9, so dividing by 3, we get c equals to 3. That's one of our variables. Again, as before, we want to substitute this one into one of the equations. Again, it doesn't matter which one you want to put it into. Let's just go for equation 1. So anytime we see a c, we'll replace it by the value of 3. So I've got 2 lots of 3 minus 3t equals to 3. So that gives us 6 take away 3t equals 3. And now we can solve it for t. So if we take 6 from both sides, we're left with 3t equals to negative 3. And divide by negative 3 gives us a positive answer of t equals to 1. And again, just to finish off, let's state the solutions to the equations. So we have c equals to 3 when t equals to 1. And that's your solution. Copy this example into your notes jotter. Okay, here's example number 2. Again, a separate system for us to solve. We have 3u take away 8v equals 11, and u plus 2v equals to negative 1. Right, so looking at these equations, you should first of all see that one of them is a negative and one of them is a positive. Different signs this time tell us we need to add. The other thing you should notice is that none of the variables have the same value. We've got a 3u and a u, and then an 8v and a 2v. So the first thing we need to do here is to multiply one or both of these by a constant so that they are the same. If we're looking at the v terms, we've got 8v and 2v. We can clearly see there that if we multiply 2 by 4, that'll give us the 8. But because we're going to do that to the v, we need to do it to the whole equation. So if we label them 1 and 2, we can start off by saying that we're going to take equation 2 and multiply the whole thing by 4. So we're going to multiply every single term by 4. So 4 lots of u give us 4u, 4 lots of the 2v give us an 8v, and 4 lots of -1 are -4. What this now gives us is a third equation to work with. And this third equation has the same value for v as what equation 1 does. That's what we need to be able to use the elimination method. Now we've already said that both of them have different signs, so we need to add them together. So we add the u terms, add the v terms, and add the constant. So if we add equation 1 and 3 this time, we're not interested in 2 anymore, we're going to be left with 7u, then the -8v plus 8v gives us 0, that disappears, and then we've got 11 plus -4, which leaves us with 7. So 7u equals 7, which tells us that u must equal to 1. So now we have our first variable, we can use this to find the second one, and as before, we can substitute this in. So sub u equals to 1 into any of the equations, doesn't really matter. Let's go for equation 2 this time, since it already has 1u on its own. So we're going to replace u by 1, so we have 1 plus 2v equals to -1, and now solve it. So we have 2v equals to -2, so v equals to -1. And there's your second solution. Again, just to finish off, u equals 1, and v equals -1. And that's the solutions to our equations. Copy this example into your notes jotter as well. And finally, example number 3. Now we're looking at the system of equations 3w plus 2y minus 2 equals 0 and 2w plus 3y plus 2 equals 0. At the minute, these are not quite in the right form for us. We don't want these numbers to be on this side. So we're going to start off by taking all the numbers over to the right hand side of the equation, so that only the variables are on the left hand side. So by doing this, we end up with two new equations. So we have 3w plus 2y equals to positive 2 this time. That is now our equation 1. And the same for the second one. We have 2w plus 3y equal to -2, which becomes our equation 2. Now they're in the correct form for us to use the elimination method. So looking at both the equations, we can see that they're both adds this time, so they have the same signs. Same signs tell us we need to subtract. Now we're looking to find whether any of the variables have the same value. We've got a 3w and a 2w, they're not the same, and a 2y and a 3y, again they're not the same. So we need to find a number that we can get them to be. There's no way that we can multiply 2 by a whole number to get it to 3, and no way we can multiply 3 by a whole number to get it to 2. So that means we need to change both of them this time. So what we're looking for is the lowest common multiple. So we want the lowest common multiple of 2 and 3. Think about 2 times table and the 3 times table. We should know that this is 6. So what we want to do here is to change both our equations so that they are in terms of 6y. So to get from a 2y to a 6y, we're going to have to take equation 1 and multiply it by 3. That gives us 9w plus 6y equals to 6. Again, we'll name this one as equation 3. If we take equation 2 this time, we can multiply it by 2 to get a 6y. That would give us a 4w plus 6y equals to -4. This is now a new equation, equation number 4. Now what you can see is that both of these equations have the same value for y. So we're ready to do elimination. We're not interested in 1 and 2 anymore, we're just going to use 3 and 4. So same signs tell us that we have to subtract. In this case, the w term, the bigger w term is in equation 3. So let's do equation 3 take away equation 4 this time. So the 9w take away the 4w, leaves us with 5w. The 6's cancel, and we've got 6 take away negative 4. Take away negative means we have a plus instead, so we end up with 10. So if 5w equals to 10, that means that w equals 2. So there's our first variable. Again, substitute this one in. So to substitute w equals 2 into one of the equations, let's go for equation 1 this time. So equation 1 is 3w plus 2y minus 2 equals to 0. If we put w equals 2 in this, we get 3 lots of 2 plus 2y minus 2 equals 0. So that gives us 6 plus 2y minus 2 equals 0, which leaves you with 2y plus 4 equals 0. Now we can solve this by taking 4 away and dividing by 2. So we get 2y equals to negative 4, so y equals to negative 2. Now we have the two solutions. So our final solution here, w equals 2, then y equals to negative 2. And we've solved by elimination. So 3 different types of elimination problems, just by giving different information in the questions. Okay, as always, here are a few questions for you to try before you go to your class. So we're looking at two systems here. 2x plus 3y equals 16 and 4x minus 9y equals 2. And then 4m minus 6n equals 7 and 5m minus 8n equals 8. Try them just now and we'll give you the solutions in a few seconds. Right, here are your solutions then. For the first system, we should have solutions of x equals 3 and y equals 0. And for the second system, m equals 4 while n equals 3 over 2. So that last one might have been a wee bit trickier. Okay, so that's us now finished the algebraic methods for solving simultaneous equations. In the next video, we'll be looking at the applications of these to real life contexts.